coordinate system, and specifically polar coordinates, right? And in this lesson, we are going to discuss how to plot the points given the polar coordinates, and how to convert or identify the polar coordinates given the rectangular coordinates and vice versa. And we are also going to solve for the conversion of an expression or equation from polar form to rectangular form. Okay, so let's start discussing some of the examples. Now, this is the polar coordinate system. It's just like the rectangular coordinate system. However, in polar coordinate system, we are plotting not the values or values, but these are not the values of x and y. Okay. Instead, we are plotting the values of the radius and its corresponding angle measure. All right. So our x-axis here is called the polar axis, where it corresponds to the value of the radius in a given polar coordinates. Okay, and this is also radius, and the broken line or lines that you can see here in the coordinate system are the indicators for the angle measures or the theta. All right, so this first quadrant is divided into 6. Therefore, each angle measure, this one is 15, this is 15, this is another 15, another 15, another 15, and another 15. So that's 90 degrees. Actually, you can make any divisions, okay, or any form of dividing this quadrant into another, or I mean into different subparts depending on the angle that you wanted to use. All right, but in this case, I am using pi over 6. Okay, if I'm not mistaken, yeah, it's pi over 6. So you can do pi over 2, pi over 4, and whatsoever. All right, so the radius is this. Again, this is what we call the polar axis. This is the positive x-axis for coordinate plane or rectangular coordinate system, right? And however, for polar coordinate system, it is called the polar axis. So the angle measures or the angle theta will always start from this axis, okay? So either it's a positive or negative, we will be starting from here. Again, if the angle is positive, the direction of the angle, okay, should be counterclockwise. All right, if we're going to plot the points or the coordinates, and if it's negative, then it should be, or its direction should be counterclockwise. All right, for negative angle measures. Okay, and let's identify. Oh, by the way, you can see here concentric circles. Now, these circles determine the radius, okay, or the radii of the given polar coordinates. Okay, so if, for example, we have, let's say 2, and let's say 60 degrees, then our point here will be, so let me just erase some of the doodles that I made, right? So let's plot the point 2, 60 degrees. So 2 is the radius and the angle measure is 60. So we are going to consider the second circle, right? Because it means it's 2. The radius is 2. This one, this is the polar axis, and 60 degrees. So this is 15, 15, 15, 15. Therefore, we're talking about this broken line here, all right? However, the radius is 2. Therefore, the point will just be plotted here. Okay, so this is our point 260 degrees. All right, or this is also equal to 2 pi over 3. So once we convert the degree measure to radian. Okay, and again, we're talking about this point. All right, now let's discuss more of how to plot polar coordinates in the polar coordinate system. Okay, so how do we plot the points? Now the point PR, okay, sorry, the point P, which is the polar coordinate with coordinates R, the radius, and the theta, the angle measure, is located at R, or absolute value of R units from the pole. And when we say the pole, we're talking about the origin. So instead of calling this as origin, we call it as the pole, okay? When we talk about the polar coordinates. So this is a pole and this is the polar axis, all right? And we consider the following. Now, if the given radius is greater than 0, the point lies on the terminal side of the theta, or the measure of the angle. So we just consider as is, whatever the value that is given in the coordinate. So if it, just like the example that we had, so if it's 2, then look for the radius 2. Okay, it could be any point on the second circle. Okay, second concentric circle, and 60 degrees. Okay, here we go. So we have this, the 60-degree angle measure. Okay, so that's what it means by condition number 1. Now, if R, or the radius, is less than 0, the point lies along the ray opposite to the terminal side of theta. So if we have a negative radius, or if it's less than 0, let's say -2. Okay, let's say -5 and 60 degrees. So how do we plot -5, okay, and 60 degree for the theta? So let's use different color. So we have -60 degrees is this. So we are using the same angle measure, okay? However, the given is -5 here. So instead of considering -5, we're just going to consider 5 or +5, because we are talking about the absolute value of the radius. So that's 2, 4, 5. So it's here. It's supposedly here. Okay, the point 560 degrees is here. Sorry, I forgot the 60 degrees. However, since the radius is negative, based on the rule, the point lies along the ray opposite the terminal side of theta. So which means that this is not the final point, okay? Where this given point, -560, which is the polar coordinate, can be found, okay? It would be found at the opposite side of the terminal side of theta. So the opposite side of this 60 is here. So 1, 2, it's here, right? This is the opposite side of the given terminal side of the angle, 60 degrees. And of course, since the radius is 5, all right, that's the absolute value of -5. So we are going to trace this 5, it's here. Or we could say 1, 2, 3, 4, 5. So it's here. All right. Here we go. So this is our -5, 60 degrees. Okay. So instead of plotting -5, plot the absolute value of 5 for you to easily identify the location of the point given -560. All right. But let's discuss more of how to plot points or polar coordinates in the polar coordinate system. Okay, let's have more examples in this. So let's have this one. Now we plot the following points with the following polar coordinates. Letter A. So in letter A, we have positive radius, which is 4, and the angle measure is 210 degrees. So let's identify. All right, since all of the values or all of the parts of the coordinates are positive, so we can just easily identify its point. So let's identify its point now. It's 4, so therefore we are talking about this, okay, the radius. So therefore this is the circle that, this is the portion where the point can be found at, but we need to find the specific location of that point. Again, this is the position, okay? or this is the location where that point can be found at. So for, the angle measure is 210 degrees. So that's more than pi, okay, or 180. So 180, 210 minus 180, that's 30 degrees, right? So it means we're just going to add 30 degrees from pi to get the 210 degrees. So that's, here we go. So this is 15, 15, that's 30. So therefore, our point can be found here, somewhere here. Okay, let's just identify the terminal side. Here we go, the terminal side of the angle 210 degrees. And of course, since the radius is 4, the point can be found here. Okay, the point can be found here, specifically here. So this is our point for 210 degrees. All right? Okay, so I hope everything is clear. So again, we plotted for 210 degrees. Oh, 210 degrees. Here we go. All right, and letter B, you can sketch the points if you want, and then try, or let's check if we will have the same answer. So our point here given is -3, 2 pi over 3. So again, we need to consider the radius, or we need to convert the radius to positive quantity. So we need to put absolute value on the -3 part. So this becomes 2 pi over 3. All right. However, this is not yet the final answer. This is just a part of the solution on how to plot the point Q, which has coordinates -3, 2 pi over 3. Okay, so where can we find 3 and 2 pi over 3? So that is the third circle, okay, in the concentric circles from the given pole. All right, so here's the 3, here's the 3, and here is the, oh, sorry, here is the 3. And, oh, sorry, that's 2. So 3 and 3. So these are just markings that will guide us where that point Q can be found at. All right, and 2 pi over 3, 2 pi over 3 is equivalent to 120 degrees, right? So 120, 180, so that's 60. The reference angle is 60 degrees, correct? 2 pi over 3, 180, 60, 120. Okay, correct. So here, where can we find, this is 30, 30, sorry, 15, 15, 15. So 30 is here. This is 120. This is the pole. And of course, this is the polar axis. And everything will start from the polar axis. All right. And let's identify the, okay, that point. So this is our angle measure. That angle measure is 2 pi over 3. Here we go, 2 pi over 3. And since our radius is 3, so we can find that point somewhere here. Here we go. However, in the given example B, which is point Q, now the given radius is negative, and our rule, if the radius is negative, is we need to find its opposite side, okay? Opposite ray. So the opposite ray of this terminal side of the point Q with a positive radius is this. So 1, 2, so here we go. We can find that here. All right. And of course, since we're dealing with -3 with an absolute value of -3 is 3, so therefore our final point is here. All right, so this is our point Q, sorry, it's Q, -3, 2 pi over 3. And what point is this? This point is, let's say Q, let's say R. QR, oh, sorry, let me just erase that. Or let's just name this as 3, 2 pi over 3, right? So this is not what we're looking for, but this is what we're looking for since the given is negative radius, all right? So this is our final answer, okay? I hope everything is fine. And if you have a question, just let me know. So let's work on letter C. Letter C, that's -2. Oh, everything is negative, all right? The radius and the angle measure are all negatives. So again, the first thing to do is to convert the radius to a positive radius. That's 2 and -pi/4. Now look at this, guys. The angle measure is negative. And as I've said earlier, when the angle measure is negative, then the direction of the uh, construction of the angle is clockwise, right? Okay, so let's identify that. So our direction is clockwise, somewhere there, and -pi/4. -pi/4 is half of the quarter, correct? So that's 1, 2, 3, 4, 5, 6. So that's 3 here. So this is pi/4, -pi/4. Okay, and this angle is -pi/4. All right, and since our angle, our radius is 2, so therefore, let's plot the point 2. It can be found here at the second concentric circle. Second circle in the concentric circle, all right? It should be lying at this terminal side, okay? Or this ray. And since originally it's negative, so from the given rule, we need to find its opposite terminal side, okay? Or the side or the ray which is opposite to this ray or terminal side of the angle -pi/4. So there we go. So that ray or segment, it can be found somewhere 1, 2, 3, 1, 2, 3. Here we go. So here we go. Here, and of course, let's plot the point by identifying the radius. That's 2. So the point can be found here, somewhere here. Okay, so this is now the point that we're looking for. Sorry, that's R, -2, -pi/4. And this is our point for the given polar coordinate. All right, and this is not the final point. This is just a guide on how to find that point R. Okay, I hope everything is clear. And okay, so we have already plotted the points. I hope everything is fine. Now let's go to identify some multiple representations of points in the polar coordinate system. What does this mean? This means, guys, that in a given coordinates or polar coordinates or coordinates, there are more than one points that can be associated to the given point. So for example, we're talking about this point, or let's move on to example letter A. So we talk about this point, which is 210 degrees. Now, there are other points which are different, okay, which have different coordinates as the given point P. However, they lie on the same exact location of point P, or where the point P is located at. So here. Now, what are those points and how do we find those points? Okay, those are the questions. So for us to do that, we're just going to use this example. All right. So how do we do it? The first thing that we could do is, since this is a positive angle measure, then we can use up a negative angle measure. All right, we can use this. So which means that we are going to copy the radius. Of course, the radius is just the same, or the radii are just the same. There are 4. And what is the angle measured here? The angle measured here is, how long is this? So this is 30, 180, so 150 degrees. So that's 4, negative 150 degrees. And they can be found, or these 2 points are found at the same location in the polar coordinate system. All right, so here. And there is another way to do that. Now, the other way is we can find its, sorry, let's use another color. We can use the negative, okay, the negative radius. Okay, so let me just use magenta. All right, we can use the negative radius, or measure of the radius here, and it can be found at -4. So that's here, right? And the point here is what? That's, this is equal to 4, and the angle measure is 30 degrees. Correct? However, we're not talking about this point. We are talking about this point. So what do we do in order to transfer, okay, this point here? Based on the rule, we just need to, since they are opposite, all right, opposite rays, they're opposite rays, then we just need to convert the radius to its negative, all right, based on the rule. So therefore, once we converted, or we change this point here, then the point becomes -4, 30 degrees. All right. And these are some of the points that can be plotted in the coordinate plane, same as the given point P, the point P here. Okay, so there are actually infinite. You could use +2 pi, you could use +4 pi, and so on and so forth. All right, so if there's not, there are more than one points that can be identified or determined aside from the given point that we have, like the point P here. Okay, so one point corresponds to many or infinitely many coordinates. All right, so it's not a one-to-one, there's no one-to-one correspondence here. It's one to many. One point is to many coordinates, or that's many is to one, many coordinates is to one point, one single point. All right, now how about this? The given letter D, Q -3 2 pi. So our final point is here, the blue one. Okay, what are the other points that we could find such that they share the same point as point Q? So to do this, we have, let's use cyan. All right, now we could have a negative angle measure here. Okay, what point is this? This point is equal to what? This is equal to 3. And what angle measure is this? This is equal 1, 2, 3, 4, 15, 60. That's pi over 3. Negative, right? So the other angle that we could find, or yeah, that we could find such that it shares the same location as point Q is 3 and negative pi over 3. That's positive. Correct? And what's the other point that we can still find? Let's find another one. Okay, we can find the positive angle with a positive radius. We can use this angle here, somewhere here. All right, so that's +3, of course. And what's the angle measure? This is what's this? Negative pi over 3. 2 pi minus pi over 3, that's 5 pi over 3. There we go. So this point is same as point Q. All right. And again, there are infinitely many points that we could identify that will share the same location as point Q, okay, in the polar coordinate system. So the difference of the polar coordinates and with the rectangular coordinates, or the points of the rectangular coordinates, that polar coordinates has 1:many, while the rectangular coordinates or points have 1:1 relation or correspondence. Okay, there is a unique point uh, for each point in the rectangular, while in polar there are no unique points that can be associated to the given point in the rectangular coordinate system. All right, that's how that's what the difference between the two. Okay, one of the differences. Okay, so let's identify other points in example letter C. R is -2 and -pi/4. And the final point is here, the red one, okay? This is the point that we got. And there are other points that we can identify. We can use this, the positive angle, okay? The positive angle measure. All right, so let me just, okay, so this angle is equal to, what angle is this? Pi/4. This is 3 pi/4. Right? 1, 2, 3, that's 45. Yeah, that's 3 pi/4. So let's identify the coordinates. The angle measure is 3 pi/4. And the radius, since it's positive, all right, so that's 2. Here we go. Okay. And what are the other points that we can identify that share the same location with point R? So we can identify, or we can make use of the negative angles. All right. Okay, let's make use of color magenta. So we can make use of this, since this is our final or the terminal side here. So we can make use of this. This is equal to negative 5 pi over, sorry, negative 5 pi over, my God. Okay, 5 pi/4, right? So our angle measure is negative 5 pi/4. And of course, our radius should be positive, since we did not translate the point to its opposite opposite ray. All right, so that's 2. Here we go. So these are just some of the points that share the same location with point R. Okay, so if we're going to analyze, guys, it's just like adding pi for us to identify the other points, or better, if you're going to plot it in the polar coordinate system. Okay, so that's how we do it. All right, now here, okay, so let's just take one example here. Oh, why letter C? Okay, let's take letter B. So in letter B, the given point is 3 pi/6. Okay, and that point could be found at pi/6, that's 30 degrees. And the radius is 3, so the radius is 3 here. So pi/6. Pi/6, that's 30 degrees. So 15, 15, here we go. So this is the point that we're looking at, or this is the point P. Point P is 3 pi/6, right? And let's identify, okay, let's identify the terminal side. Here we go. And again, this is our point. Oh, sorry, it should be magenta. All right, and we find another representation of this point in which the given condition should be applied. So R is negative. R should be negative, and the theta should be within 0 to 2 pi. All right? So theta here. Here we go. So if we're talking about, let's make use of gray, blue. Okay, if we're talking about negative radius, so the radius should be, or I mean the terminal side should be here, right? Because this is the opposite, all right? And that's 3, so that's the point should be, sorry, the point should be found here. And this point is, right, find another representation. Okay, here we go. So the point should be, okay, wait a minute. Okay, the point should be -3. And this must be what is the measure of this angle? That's it. This is just equal to pi, right? Okay, that's 7 pi over 6. Oh, sorry. Or this is the +3. And of course, the point should be found here, and it should be -3, 7 pi over 6. All right, because we need to translate this here, and that's the time that it becomes negative. So this must be positive as our reference point. Okay, so once we turn this radius to negative value, then this point will be translated here, the same as point P. That's why 3 and pi over 6 is the same as -3, 7 pi over 6. They share the same point or location in the polar coordinate system. Okay, I hope everything is all right. All right, now let's move on to how do we convert, or how do we convert polar coordinate expression or equation into rectangular rectangular, okay, expression. Sorry, rectangular coordinate expression. Or should I say, how do we convert polar form into rectangular form? Okay, we might be talking about the equation or just an expression. So here, in this lesson, we are going to convert polar form to rectangular form or vice versa. All right. So now here's the technique or the rules on how to convert the coordinates. Okay, polar to rectangular or rectangular to polar. Okay, so to do that, now we're just going to make use of these formulas. Okay, so polar to rectangular, the given r theta should be converted into xy. All right, and how do we solve for xy? X, we know that x is just cosine, so that's r cosine theta, given the angle, okay, and the radius. And for the y, that's just r sine theta, given the angle and the radius. Okay, now how did we get this? How did we get this formula? Okay, so let me just explain how we got that formula. All right, now let's just let's make use of this slide. Okay, now let's say this is our polar coordinate system. Okay, and with a point here. All right, with a point P, let's say. Okay, again, this is our rectangular coordinate system. Let's just make use of the unit circle. All right, so this is equal to, let's say this point is equal to xy. This is our radius and this is our theta. All right, and we know that sine theta is equal to, this is our y and this is our x. This is y over r. So we could say that y is equal to r sine theta. Okay, and for cosine theta, that's just x over r, x over r. And we can express x in terms of cosine theta and r. So x is equal to r cosine theta. So Given, guys, the radius and the theta, okay, in a form of coordinates or a point, all right, or it is an expression of a polar coordinate, correct? Then we could convert this into uh, an expression in a form of rectangular form, or in rectangular form, I mean, xy, where x is r cosine theta, while y is r sine theta. All right, so we use trigonometry here. Okay, here we go. So this is how we got this formula. All right, and if we're going to convert rectangular form to polar form, then we are going to use this tangent y over x and of course the radius x squared plus y squared. Okay, how do we do that then? Now, since we knew the values of x and y here, again, we're now converting rectangular to polar. All right. So given xy here, now for us to identify the angle measure, then we simply use theta or tangent theta. That's y over x, since our givens are y and x here. Okay. Okay, and for us to identify theta or the angle measure here, we're going to make use of the inverse tangent. So that's inverse tan of y over x. And we can identify now the angle measure, okay, of the polar form. And for us to identify the radius, of course, we can make use of the radius here. And we know that radius square is equal to x squared plus y squared with the use of the Pythagorean theorem. And of course, we can solve for r by taking square root on both sides. So that's square root of x squared plus y squared. And we can identify the r. All right, so which means that converting from one form to another form, polar to rectangular or rectangular to polar, it's just using the same concept, which is the unit circle or the right triangle in the xy plane, okay? Using the trigonometry, of course. Okay, so let's apply this, okay? Let's apply this rule by answering some examples. All right, so let me just erase everything here. There we go. So now let's take example number 3 and let's deal with letter A. So that's 2 pi over 3. And we're going to convert polar to Cartesian points, to rectangular coordinates, okay? Or Cartesian, right? That's why it uses letter C, or you can use R if you want to. So we're solving for x and y here, right? And again, for us to identify the values of x and y, we will be using the trigonometric formulas, which are x is equal to cosine or r cosine theta, and for y, that's r sine theta. Okay, so our r here is equal to 2, and our theta is equal to pi over 3. And we just need to substitute these values in the given formula. So we have 2 cosine pi over 3. And pi over 3 is just 60 degrees. And of course, the unit circle would help us to identify its value. So 2 times what is cosine pi over 3? Pi over 3 is just 60. So this is 2, this is 1, and this is square root of 3. That's 1/2. So this is equal to 1. All right, and let's solve for y. This is 2 sine pi over 3 and 2. And sine pi over 3 is equal to opposite over hypotenuse. That's square root of 3 over 2. Sorry, square root of 3 over 2, and this is equal to square root of 3. So therefore, the equivalent, okay, of the given polar coordinate, which is 2 and pi over 3, is equal to the rectangular coordinates with abscissa of 1 and ordinate of square root of 3. All right, so this is now our rectangular coordinates or Cartesian point given the polar point. Okay, all right, so let's work on letter B. So our example letter B is -4, -pi/4. So here our radius is equal to -4 and our theta is equal to -pi/4. So again, to convert this polar point to rectangular point xy, okay, C, then we need to make use of the formula. X is equal to r cosine theta, and y is equal to r sine theta. And our radius is -4 cosine -pi/4. And here is -4 sine -pi/4. All right, so let's make use of the unit circle for us to identify the values of cosine and sine with -4 pi/4 angle. Okay, so this is our, -pi/4 angle. Since it's negative, so it should be found at the fourth quadrant. So this is just equivalent to 45 degrees, right? -45 degrees. So this is square root of 2, square root of, square root of 2 negative, of course, and this is equal to 2. All right, again, this is square root of 2, square root of negative square root of 2, and 2. Okay, or you can make use of another values. All right, so let's say this is equal to 1, this is -1, and this is equal to square root of 2. Now, both will give you the same values actually, all right? Okay, so we have -4 times, what is cosine of -pi/4? Okay, so cosine is 1 over square root of 2, right? 1 over square root of 2. This is equal to -2 square root of 2. Sorry. All right, -2 square root of 2. And how about -4 sine -pi/4? Sine is negative, so -4 times sine, that's opposite over hypotenuse, -1 over square root of 2, which is equal to 2 square root of 2 positive. Okay, so if we use this, we'll get this. Now let's try using this one. Let's see if we'll get the same. So now let's write it down. -4 times cosine, that's square root of 2 over 2. Of course, we'll get the same answer. And how about for sine? So -4, negative square root of 2 over 2, that's positive 2 square root of 2. So either way, we'll get the same answer. And our equivalent coordinates, okay, rectangular coordinates of the given polar point, which is -4, -pi/4, is what's that? -2 for x, square root of 2, and 2 square root of 2 for y. Okay, so this is now the equivalent point in rectangular form using the given polar points or polar point. All right, so we have already converted these 2 points here, 2 polar points specifically. I hope everything is fine. Now let's do the reverse, okay? Now, given a Cartesian points or rectangular points, we need to convert this to polar points. So let's deal with letter A first. So that's -2, C, and we need to identify the radius and the angle measure. This is the P, or the polar point. All right, so we better make use of a triangle here, or draw the location of the point. Sorry for the drawing. So 2, -2 can be found at the fourth quadrant. Oh my, here we go. So this is 2, negative 2. So this is negative 2, and this is 2. Therefore, this is 2 square root of 2. All right, and this is our theta here. Okay, so we have already, we easily identified the radius, which is 2 square root of 2. All right, we already identified this. And the remaining part is the theta. So for us to identify the theta, again, we can make use of the tangent. Theta is equal to y over x. And theta is equal to the inverse tangent. What's that? Our y is negative 2. And our x is equal to 2, which is equal to inverse tan of negative 1. Okay, and what is the measure of the angle here? Now the angle is at the, what's this, is at the fourth quadrant, right? So it's either we use the negative measure of the angle or the positive one. Either way, we'll get the same answer. Okay, because we have already identified, we have already solved, right, and determined, and we have learned that there are more than one point. Okay, there are more than one point, or there are more points that can be used to identify the location of the single point. Sorry, there are more. Sorry for that. There are more than one point that can be used, or coordinates that can be used to identify a point, okay, in the, or the exact location of a point in the polar coordinate system. All right, that's what I mean. Okay, so here, since it's positive, the x and y are equal actually in quantity, okay, as a measure, disregarding the negative here. So therefore, this triangle is isosceles, right? So both acute angles are 45 degrees. So there are 45 degrees, okay? Or this could be expressed as negative 45 degrees. 45 degrees is just a reference angle. And what's that? 45, 360, 315 degrees. Or this is negative pi over 4, or pi over 4, 8, that's pi over 4, 7 pi over 4, correct? 7 pi over 4. Let me check. Yeah, 7 pi over 4. Okay, so our point now is in polar form. Let's make use of a different color. So the coordinates 2, negative 2 in rectangular form is equivalent to a polar point or coordinates with radius 2 square root of 2, and theta is equal to negative pi over 4, or it could also be expressed as 2 square root of 2 and 7 pi over 4. So it shows that it suffices, I mean, it shows that our claim a while ago is correct, that one point, okay, one polar point can be associated to more than one coordinates, okay, polar coordinates, or even rectangular coordinates, okay, because we can convert this, one rectangular coordinates and more than one polar coordinate, since these polar coordinates can be converted into one rectangular coordinates. All right. Okay, so these are our answers. Okay, now let's work on letter B. Let's work on letter B. Letter B is negative 1 square root of 3. This is our Cartesian point or rectangular points. So, sorry. So our x is equal to negative 1 and our y is equal to square root of 3. And again, drawing the triangle, or the point in the rectangular coordinate system helps a lot. So x is negative and y is positive. So we can find that at the second quadrant. Here we go. So this is our, let's make this a different color again. This is -1, and this is our square root of 3. And we're looking for, we're looking for theta here. All right. So we're looking for theta, and at the same time, we're looking for the radius, because these two quantities are what we're looking for us to convert the Cartesian points or rectangular points to polar form or polar points. Okay, so radius is easier to find because we know that the radius is equal to -1 square plus square root of 3 square. Oh, this is 3 square root of that. So this is equal to 1 plus 3, and this is equal to 2. So our radius is equal to 2. Okay, and for our, let me change the color. For our theta angle measure here, now we can easily identify the theta here since these two values are values of a special angle, right? This is equal to what? This is equivalent to 60 degrees or pi over 3, right? The reference angle. But again, our true angle should be coming from the positive x-axis, okay? Here, since we are talking about the rectangular coordinate system or plane. Okay, and if this is pi over 3, this is 2 pi over 3. Or this is what? 6120 degrees, correct? Now let's check if our answer is correct by using the formula tangent theta is equal to y over x, and theta is equal to tangent, inverse tangent, what's that? Y is square root of 3 over -1. Okay, so how do we solve this? This is theta inverse negative square root of 3. There we go. All right, so negative square root of 3 again can be found here, and still the same. We have, what's that? We have 2 pi over 3, of course, for the angle theta. Okay, if it's special angle, then we can easily identify using the unit circle here, okay, by drawing the triangle or finding the location of the points given, and then drawing a triangle, constructing a right triangle here, and finding the reference angle, of course. All right, so therefore, the equivalent polar point is now r theta is equal to, wait a minute. Okay, here we go. Radius is equal to 2, and the angle measure is 2 pi over 3. All right, this is now the polar form, okay, the equivalent polar form of the rectangular form or rectangular points. All right, and I hope we got the same answer. Okay. All right, and I hope everything is okay when it comes to conversion from rectangular points to polar points and vice versa. Okay, now let's move on to our next subtopic, which is expressing the following Cartesian equations to polar equations. Now, how do we do that? How do we convert the Cartesian equation, this one, to a polar equation? And what do we mean by polar equation?